Hello guys, welcome to this channel and thanks for viewing this video. Don't forget to like, to comment, to share, to subscribe to this channel in order to get more videos like this one. Today I'm going to be talking about data type conversion or typecasting. So let's begin. Typecasting or data type conversion is actually when a value of a data type is treated like another data type. Or in other words, it is when you assign a value of a particular data type to another data type. For example, when trying to convert a decimal number into an integer number. In Java programming language, there are actually two types of data types conversion. So the first type is what is called the implicit type coercion. It is also called the widening casting. So this type of data type conversion is done automatically, and it is applied when we are trying to convert a smaller data type into a larger data type. So in terms of data type size, and when I'm talking about data type size, I'm simply talking about how big of a value a certain data type can hold. And if you can recall in a video we did on data types, we could see that certain data type hold larger numbers than other data types. For example, the double data type holds larger numbers more than the integer data type. So this implicit type coercion is applied when we are trying to convert a smaller data type into larger data type. For example, the integer into a long data type, or a long data type into a floating point data type, or a float data type into a double data type. Or it can even be the integer data type into a double data type, which is a decimal number data type. So it is always from the smaller data type into the larger data type. So this is how it goes in terms of implicit type coercion. So a typical example of this implicit data type conversion can be illustrated in the case of a mixed arithmetic expression. As you can see on my screen here, I have this expression inside the brackets here, 5 plus 9.6, which is a mixed expression because I have an integer, 5 here is an integer, and then 9.6 is a decimal number. And if you can recall, in the previous video I made on arithmetic expressions, and I talked about mixed expressions involving integers and decimal numbers, we could see that in such operations or in such expressions, the integer is always treated temporarily as a decimal or a floating point number. So that's the reason why if I run this expression, you will see that I will get a floating point number. So here I have 14.6 because 5 here is being treated not as an integer, but is being treated as a floating point number, and its decimal part is considered to be 0. So it's just like I wrote 5.0 plus 9.6, and that is giving us 14.6. Or I can also give another example. Let me say, for example, I will declare and initialize a variable here. I say int number is equal to 5, and I will say double another. I will declare and initialize another variable. I will say double, and I call it decimal number, and I will say that it's equal to number. So it's just like I'm trying to pass the value I have stored in number in my int variable here. I want to pass it inside the decimal number here. And you will see that if I do a system.out that print line of my decimal number variable, okay, I will get 5.0. Yeah, so I'm getting 5.0 because decimal number is of data type double, and the conversion has been done automatically. So as I said, this kind of type conversion happens automatically, and sometimes we may not even notice that the conversion has been done. And so that's the reason why it's always important to be careful if we do not want our program to throw unexpected errors. And this leads us to the second type of data type conversion, which is called the explicit type conversion, or it is also called the narrowing casting. So this explicit type conversion is done manually, and it happens when we are trying to convert larger data types into smaller size data types. So always remember, when I'm talking about size here, I'm simply talking about in terms of how big of a value a certain data type can hold. Okay, as we could see in the case of data types, the double data types hold larger value than the rest of the data types. So here it's like we're trying to convert double data types into integer data types, for example. And most of the times, this type of conversion, this explicit type conversion, is done manually, and it's also done in order to avoid the implicit type conversion, okay, to avoid the fact that the conversions can be done manually. So since it's done manually, I'm going to show you how to write its code. So I'm going to give an example. I will leave this variable here. Okay. Let me just remove this one. So I will call this variable decimal number, and I'm going to give it a value of 5.96, for example. And I will have another variable of data type integer, and I will call it number. And I want to convert my decimal number here, and that conversion, I want to store it in my integer variable. So what I'm going to do is I'm going to open the brackets, and inside I will write int. Int here is for integer data type. And then after, I'm going to write my variable decimal number. So remember that decimal number here is this variable, and its value is 5.96. And I'm passing this value to my variable number, which is an integer. And I am, since the value I'm passing is a decimal number, I want to force the conversion of that value by writing int inside the brackets here. So now if I do a system.out that print line of my integer data type, which is number, so I will write system.out. Sorry. It's a number here. I'll also just copy this. And inside here, I will say decimal number. And I run it. So you see that the first value to be outputted will be the variable number, and it's 5. Why 5? Because I forced its conversion. Okay, so it dropped the decimal part of the number that I passed to it, and then the second value is decimal number is 5.96. So this is how you write the code for explicit data type conversion, or the narrowing casting. So I can give further examples. I will write another, let me just write a system.out.println, and inside I will say double 17 divided by 2. If I run, so I have 8.5. Why did I get 8.5? Because the expression that was evaluated first was the double here inside. This double converted the 17 into a floating point number. So the 17 became a 17.0, and then that 17.0 got divided by 2. That gave us 8.5. So this 2 got also treated as a floating point number. So that's why we got this value. But if I change this expression, you will see that I will get a different value. I will change the expression and put 17 divided by 2 inside the brackets. And let me remove this. And if I run my program, you'll see that I will get 8.0. The reason why is because I put 17 divided by 2 inside the brackets. And if you recall, according to the order of precedence, the operations or the expressions that are inside the brackets have the highest level of precedence. So before converted, I had the program had to, evaluate this operation 17 divided by 2. Since the two of these numbers are integers, the result that will come out of this operation will be an integer number. So 17 divided by 2 will give us 8 in terms of integer, and that 8, if we convert it into a decimal number or a floating point number, will give us 8.0. So that's actually the logic of it. But if we remove the brackets, you will see that we will get 8.5, because the program will deal with this expression differently from the way it will deal with the previous one, simply in terms of order of precedence and what we saw in the previous videos. So that's it. I can give another example again. Let me say, example, instead of putting double here, I will put int, and I will say, I will put inside the brackets, and I will say 5.4 plus, and inside here I will say double, and between the bracket 15, and I will divide it by 2. Okay, I'll close the brackets in. If I run this, I have 12. Why did I get 12? Because so here, this 15 got converted into a floating point number. So 15 became 15.0. And if I divide it by 2, 2 also will get converted because it will be converted implicitly. according to the rule we just talked a couple of minutes ago. So I will get 7.5. So now 5.4 plus 7.5 will give us 12.9. But since here I put int inside the brackets here to force the conversion of the result of this expression here, that's why I'm getting 12. Because I said, okay, that result, even though it's a floating point number, but I want it to be converted into an integer. So if it's converted into an integer, I definitely have to drop the decimal part of that number. You see, so that's pretty much it. If I also change this expression and remove this bracket here, and say like this, you will see that I will get a different result. The pretty much same result. What did I get wrong here? Sorry. So I will say int. Now say 5.4. And I'll say double. And here I'll say 15 divided, no, 17 divided by 2, semicolon. Okay, so I'm getting 13. Why am I getting 13 is because here, what is happening is in terms of the order of precedence, 17 divided by 2 will get evaluated first. And since the two numbers are integers, I will get 8 out of this operation. And that value 8 will be converted into a decimal or a floating point number. So I will get 8.0. And then 5.4 plus 8.0 will give 13.4. So that 13.4 will be converted into the integer because I forced the conversion here. I did the conversion manually here by putting the int into the bracket here. So that's why I am getting 14. So that was pretty much it. You will see that if I put the brackets here, the value will be, yeah, pretty much the same value, but because I'm converted into integer, so we will now see the decimal part of the value. And so that was pretty much it concerning the type conversion, the data type conversion. And I hope the video was informative, and don't forget to like, to subscribe, and to share this video. And thanks for viewing. Let's meet in the next video. Thanks a lot.